Hey, Algebra 3. This video lesson is going to be over sections 5.4, 5, and 6. These are just all different types of ways of factoring polynomials. So that's what we're going to do is factoring polynomials. And the first way that we have here in this section is we're going to be factoring a monomial from a polynomial, and then also something called factoring by grouping, which is a technique of factoring. So let's look at those things. To let you know what factor or factors mean is this right here. To factor an expression means to write the expression as a product of its factors. Okay, and say that you had, if A times B equals C, then A and B are the factors of C. So two things that multiply together to get another number, those are the factors. Something else that we'll need to know is something called the greatest common factor. The greatest common factor of two or more numbers is the greatest number that will divide without remainder into all of the numbers. For example, we have the GCF, the greatest common factor, of 27 and 45 is 9. That's the biggest number that will divide into both of those numbers without a remainder. Some other things to know is a prime number is an integer greater than 1 that has exactly two factors, 1 and itself. And a composite number is a positive integer that is not prime. So anything that is not prime, well, is a composite number, as long as it's positive. And then prime factorization, we can use this to help us in figuring out the GCF of many numbers. So the prime factorization breaks down like this. We can take 24 and break it down into all of its prime factors. So 2 times 2 times 2 times 3 is going to equal 24. All right, so let's look at something else. On this example right here, it asks us to determine the GCF of 24 and 30. And in this example, I've already got it broken out for you that 24, we should know prime factorization is this right here. 2 times 2 times 3, or 2 times 2 times 2 times 3. And then 30, the prime factorization is 2 times 3 times 5. So from this, breaking it down, each of these numbers into its prime factorization, we can find what factors are in common with both of these numbers, 24 and 30. And the two numbers that are in common are 2. There's only one factor 2 in this number here, and 3. There's only one factor 3 in each of them. So therefore, the 2 times 3 equals 6. 6 is our greatest common factor of 24 and 30. All right, so let's look at this right here. Before we get into factoring monomials from polynomials, we need to know how to determine the GCF of two or more terms. So that's what we're going to do in these examples right here. I am given 6p, 4p squared, and 8p cubed. And I've already told you that the GCF is 2p. Let's determine that by breaking it out in its prime factorization. So 6p, the prime factors of it are 2, 3, and p. Let's say 6p equals this. And let's do 4p. 4p squared equals 2 times 2. And then p squared breaks out to p times p. Then 8p cubed. That breaks out to 2 times 2 times 2. And then times p times p times p. Alright, the values that are in common with all three of these numbers here are 2 and p, 2, and P, 2, and P. The 6P doesn't have another 2 in it, so this is the greatest common factor, 2P, which is what we were told from the beginning. Let's do the same thing with this. The greatest common factor between all three of these terms right here is xy squared. Because 4 here and 3 and 2, there's nothing in common with those three numbers. There's no factors in common. So there's no number that's going to go in front of xy squared here. And then we have x squared, x, and x. So only one of those x's is going to be part of the GCF. And then y squared, y4, y squared. So out of that, y squared and y squared right there, those two are the same, but what's in common between y squared and y to the fourth is y squared. So that's how we get y squared is the greatest common factor between all three of these expressions here. Okay, so to factor out a monomial from a polynomial, first we need to determine the GCF of all of the terms in the polynomial. So let's look at this. 24x and 16x cubed. The GCF between all of these terms, or these two terms, is going to be an 8. 8 is common, in common between 16 and 24, and an x. And we're done. That's the GCF. Okay, once we find the GCF, this is how we're going to factor out 8. We know 8x is the greatest common factor, so we put this on the outside of our parentheses. And what is left over from dividing 24x and over 8x is going to be 3. And then for the next one, if we take 16x cubed and divide it by 8x, we're going to get a 2x squared. So there we go. We have factored a monomial, which is just one term, out of our polynomial. Now, a good way to check that you did factor it properly is to use the distributive property. Distribute this 8 back out, and you should end up right back where we started. But this right here is our solution to this example. We have factored this polynomial completely. Now, factoring by grouping, we can do this with quadratics, quadratic polynomials, and we can also do this with cubic polynomials. That's what we're going to be using it the majority of the time, is in cubic polynomials, and you'll see me do that in some examples. But factoring by grouping is this right here. So for example, take this example right here, and grouping means I'm going to group my first two terms together, my last two terms together. Then factor out the greatest common factor between these two terms, which is x, and so I end up with this right here. And then also factor out the greatest common factor between the last two terms, which is 3. So I get this. Now, factoring by grouping, what I get next is, well, x plus 7 and x plus 7. It always should end up with these factors are the same right here. And so taking that factor out, I end up with just one factor of x plus 7, and what I'm left over with is x plus 3. So put that over here in parentheses. So that's how you do factoring by grouping with a quadratic. So let's do another example here. Okay, this is just the method of factoring by grouping, the steps of it. So follow these steps and you'll be good. Alright, so I have a quadratic right here. I'm going to show you this factoring by grouping method, but I'm also going to show you the Berry method and that we have learned in Algebra 2 before. So let's look at this one. Now, factoring by grouping on this one, I only have 3 terms here. So what I need to do is split this middle term right here into 2 different terms in which I can factor out something with the first 2 terms and then the last 2 terms. So my middle term, what I'm going to do is this. I'm going to say, let's take out so it's going to be a 1x plus 8x plus 4. 1x plus 8x does give us 9. And now do the factoring by grouping. Factoring by grouping. Group together these 2. Group together these last 2. The greatest common factor between the first 2 terms is just an x. And I'm left over from the first 2 terms the 2x plus 1. And then my last 2 terms, the 8x plus 4, the greatest common factor in that is 4. And when I take out a 4 from my 8x, I am left with 2x. When I take out a 4 from 4, I'm left with plus 1. So there we go. I do have the same thing in both of these factoring. And now what I do, write that one just once. And then what's left over after taking an x, or 2x plus 1 is x plus 4. So x plus 4. So this is one way you can factor, or a way that you may be able to factor some of your quadratics is by this method here, by grouping. Alright, let's look at the factoring by grouping method again. And this is also a quadratic, and they've already got, on this first example here, the middle term split up into what it needs to be. So, first step on this one is just group together the first 2 and the last 2 terms and begin factoring out the greatest common factor between the first 2 and the last 2 terms. So the greatest common factor between 4x squared and 6x is 2x. And taking out a 2x from the first term, you're left with 2x. Taking a 2x out from 6x, you're left with 3. Alright, factoring out the greatest common factor between the last 2 terms, we're going to get a 3 for the greatest common factor. Factoring out a 3 from 6x, we get 2x. And then factoring a 3 out from 9, we get 3. So, again, we end up with same thing in each of these parentheses right here, which is what we need. And then we're going to take what's in that parentheses, write it once, and then what is left over, write it in another set of parentheses. So 2x plus 3. And we're done. Alright, now this is the first factoring by grouping that we've used in this video here for cubic polynomials. Cubic polynomials, the highest degree in the polynomial is 3. But the steps are the same. Make sure it's in descending order. So we have 3, 2, 1, then no x value, 0. And follow the steps. Group together the first two terms and the last two terms. So when we do that, we end up with factoring out the greatest common factor between the first two terms is going to give us ax squared. Taking out x squared from x cubed, we're left with x. Then taking out an x squared from x, or 6x squared, is just 6. Okay, let's do the same thing with the last two terms. Now, this one's a little different because we have a minus sign in both of them. So let's take out the minus sign in this case because we need a plus sign in our parentheses. So the greatest common factor between -4 and -24 is -4. And when we factor out a -4 from a -4x, we get a positive x. Factoring out a -4 from -24, we get a plus 6. So again, same thing in both of our factorings here. Both sets of parentheses are the same. So take that, x plus 6, and then put in parentheses what is left over, the x squared minus 4. This can be further reduced, but I'll show you how to further reduce this in the next section when we learn how to factor a difference of two squares. Okay. Alright, so factoring trinomials. Okay, so what we're going to be doing in this one is factoring trinomials. And in trinomial, the majority of the time in this section, our trinomial is going to be a quadratic, meaning that the highest degree is 2. And our trinomials are meaning 3, are going to be of 3 terms. So 1, 2, 3 terms in our polynomial. Now, in factoring these types of polynomials, we're doing the reverse process of FOILing. So we should know how to do the FOILing method to multiply these two out. So we've done that in a previous section. And but what we're doing in this one is taking this form and going backwards, going back to the factored, the two factors that this polynomial multiplies to. Okay, so let's look at factoring. Okay, again, whenever we are factoring our trinomial, that is in this form right here, what we do is, this is how I normally do it. I write out my set of parentheses, place an x in here, especially if it's x in this form right here. There's no value of a before x squared. We'll look at how to factor the ones that have a number before x squared. But this one right here, we just write out x and x, and then what goes in these question marks are the two factors of c that add up to b. Okay, so here is just the FOILing process right here. If you want to take a look at that, this is how you do FOILing. Multiply the first, the outer, the inner, and the last, and you get this expression here. And when we do that, the outer and the inner, they're always going to be like terms, so we add those together to get this expression. Now, these are just the steps that I explained in the previous slide. You can take a look at these and see how it explains it. I'm going to go on to the next slide. Now, factoring in this example right here, already written out for us, we have x squared plus 8 plus 15. So again, following the process, just write out your parentheses, place the x in it as your first term. And then what goes in these question marks are factors of 15 that add to 8. So the factors of 15 that add to 8 are 3 and 5. So that is what goes in the question marks, 3 and 5, like this down here. Now, part B here of this example, I have x squared minus 10x minus 25. This polynomial is known as a prime polynomial because it cannot be factored. There are not two factors of negative 25 that add up to negative 10. Now, if this was a plus sign right here, there are two factors of 25 that add up to negative 10, negative 5 and negative 5. So negative 5 times negative 5 is positive 25, and those two factors will add up to be negative 10. But since this right here is a minus sign, it cannot be factored. So this is called a prime polynomial. Alright, so let's look at these and factor these examples here together. Alright, on this first one, what we need to do is, well, we need to check, first of all, can we factor out the greatest common factor in this, just like we did in the previous section in this video. Factor out that monomial first, which the value that is in, the greatest common factor between all three of these terms is going to be 2. So let's take out a 2 first. So a squared is left over from the first term, and 6a, and then 16. Alright, so now that we have it factored, the monomial factored out, let's factor out what's in this side of this parentheses. So I'm going to go ahead, break it apart, place my a here and my a here. Now what I'm looking for are factors of negative 16 that add up to negative 6. And I'm going to just go off the side here. 16. We can break 16 apart in a few different ways. But one that I can think of that the two factors that add up to negative 6 are negative 8 and positive 2. So that's what's going to go in these blank spots here. Minus 8 and positive 2. And we're done with that one. We're done factoring. Let's do the same thing with part D here. First, start out by seeing if we have a greatest common factor between all three of our terms here. And we do. We can factor out a 2, because that's in common with all three. And then also a z cubed. So let's take out a 2z cubed. And then put what's left from those three terms in this set of parentheses. So take a 2z cubed away, you get z squared. Take out 2z cubed from the 16z to the 4th, you get an 8z. And then take away 2z cubed from the 30z cubed, you get 15. Alright, now let's factor this portion of it that's in parentheses. We're going to keep this factor on the outside. Break this apart. and place your z here and here. And now we're looking for two factors of 15 that add up to 8, and that's going to go in these spots here. So two factors of 15 that add up to be 8 are 3 and 5. So place a plus 3 and a plus 5 here. And we're done. That is factoring, that's factored completely there. Let's go on to another part. Alright, so the next type of factoring method I'm going to show you is something called the Berry method. Your book does something called the trial and error method, and I don't like this method because it just takes too long, and the Berry method is very precise on how it's done. And what we use the Berry method on is our problems that need to be factored, that are quadratic, that have this value of a that is something other than 1. Like this example here. Our value of a in this one is 2. So this is how the Berry method is going to go. Again, we're going to separate this out into two sets of parentheses. The Berry method, it says to start out by placing your, like you do your x in the first set of your parentheses, and then the other first part of your other set of parentheses. But this one we're going to put a 2x and a 2x. I know that whenever we multiply these two out in the FOIL method, that it's not going to multiply to 2x squared. It multiplies to 4x squared. But that's just part of this method. We'll get to that here in a little bit. We'll address that. Now, what we do is we multiply together the 2 and the 4. So the first number in the trinomial, the polynomial here, and then the last. So the leading coefficient and the constant. Go multiply those two together, which is 8. And then what we do is we take 8 and we find factors of 8 that add up to 9. So factors of 8 that add up to 9 are going to be 8 and 1. So place an 8 and a 1 in this spot in your parentheses. Now, like I said, this is not going to multiply back out to our original expression here, the 2x squared plus 9x plus 4. So what we do in the next step is, if there is anything we can factor out between these two terms and these two terms, we do it in this step and we just throw it out. So the term that the greatest common factor between these two numbers in the first set of parentheses is going to be 2. Let's take that out. So 2. And then what's left over from it is x plus 4. There is nothing in the second set of parentheses to factor out, so just leave it as it is. 2x plus 1. And this 2 out here, we're actually just going to get rid of it. It does not matter anymore. This is our solution. X plus 4 times 2x plus 1. And if you do multiply these two out, FOIL this all out, we will end up back here. Okay, let's do that Berry method again, just to make sure y'all understand it. In this Berry method, again, whoops, let's do that again. 4x and 4x. Multiply 4 and 9, you get 36. So we're looking for factors of 36 that add up to negative 13. And what those factors actually are what we began with, 4 times 9. But here we have to make them add up to negative 13. So both of these are actually going to end up being negative 4 and negative 9. So negative 4 and negative 9 multiply to positive 36 and add up to negative 13. And we're almost done. So this next step, what we do is factor out any greatest common factor in each set of our parentheses. The greatest common factor in our first set is 4. And there is nothing in our second set that will factor out. So we end up with, not 4, sorry, x minus 1 times 4x minus 9. Toss this, and this is our solution. Okay, again, if you want to check your factoring to see if it has factored out in the correct way, do your foiling, foil all this out, and you should end up back here. Okay, so we're almost done. I have 3 special factoring formulas that we're going to be looking at, and you will have the use of these formulas on your test. I will give these to you, so you don't have to worry about memorizing them. So this is called the difference of two squares, and this is how it factors out. You have a value that's squared minus another value that is squared. That's where we get difference of 2 squares. And this is the factoring pattern that it has. You split it out as a plus b times a minus b. Okay, so let's look at this first example here. We can rewrite this as x squared minus 7 squared. So this is what's going to go in for a in this factoring pattern, and this is going to go in for b. So split it out as x plus 7 and x minus 7. Okay, and you're done. That's how you use the difference of two squares. Okay, this last one is a little different. I'm going to do kind of the same process. We can rewrite this first term as 2x squared squared. Because if we square this all back out, we would have to square 2, which is 4, and square x squared, which is x to the 4th. So this whole value that's inside my parentheses, that is what is going in for my a in each of these parentheses up here. Okay, now let's do minus 25y to the 8th. I'm going to rewrite that as something squared. So 25 is 5 squared. And then y to the 8th is y to the 4th squared. So there we go. This right here is my a, and this is my b, and I'm going to split it out into this factoring pattern that is up here, this formula. Let's do that. So we're going to get 2x squared minus 5y to the 4th. And the same thing except plus. So 2x squared plus 5y to the 4th. And we're done. All I have for you now is just a couple more things. I have the sum of 2 cubes and then the difference of 2 cubes and their formulas. So again, we're going to have a value that is cubed plus another value that is cubed. So this one, the sum, meaning we're adding 2 things together. And this is how it breaks out. So we need to figure out what our A is and our B is. I'm going to rewrite this problem as k cubed. So k is our A. And then a way to write 8 out as something cubed is 2 cubed. So 2 times 2 times 2, that's 8. Alright, so my k is going to be my A, and the 2 is going to be in for my B. So it's going to split out just like this factoring pattern has up here. So A plus B, so k plus 2, and then k squared minus A times B, so 2 times k, or k times 2, and then plus B squared. And B squared is 2 squared, so that is 4. Now this doesn't factor out any further than that, so don't worry about factoring that quadratic any further. Once you get to this point, you are done. So let's do the same thing with this and this. Rewrite it just like we did in the difference of 2 squares. So 27, something that is cubed that is equal to 27 is 3. 3 cubed. So I'm going to rewrite this as 3c cubed. Then the next one, 25d cubed. Well, a value that is cubed that equals 125 is 5 cubed. So 5d all cubed. This right here, 3c, is going to be my A in the factoring pattern above. And then my 5d is going to be my B. Let's factor this out. So 3c plus 5d. And then the next part is going to be 3c squared. So I'm going to write this as 3c squared. And we're going to have a next step where we simplify this a little bit more. Minus A times B, so 3c times 5d. We can go ahead and do that in the next step, but I'm just going to write it out. So 3c times 5d. Then plus b squared, so 5d squared. Now, nothing changes about this parenthesis, so just rewrite it as 3c plus 5d. And then I'm going to combine things in this one. So 3c squared is 9c squared. And the 3 times c, all of this combined together, all that multiplied together, I get minus 15 CD. And then plus 5D squared, so 25D squared. And then I am done with the process of doing the factoring pattern for the sum of two cubes. Last thing I'm going to show you is the difference of two cubes. And just like the sum of two cubes, we're looking for what is our A and what is our B, and we're going to plug it into this formula here that we are given. So P cubed and 1, you can cube that or square that or anything, and it still stays 1. So P is my A and 1 is my B. And so it splits out like this. So P minus 1, P squared plus, now 1 times P, so just P, plus my B squared, just 1 squared, which is just still 1. and I'm done. Okay, this next one, I need to figure out what my A and my B is, so I'm going to change this up a little bit. So 64, something that is cubed that equals 64 is 4. So 4 times 4 times 4 is equal to 64. So 4x all cubed. This is going to be my A. And then again, we have 125. We know that from the last one. It's 5 cubed, so 5y cubed. So 5y is going to be my B. So 4x, whoops, minus 5y. Then 4x squared, I'm going to write that out, 4x all squared plus 4x times 5y plus 5y squared. Now I'll just simplify it a little further. So 4x squared is the same thing as 16x squared. And then 4x times 5y, that gives me 20xy. And then plus 5y squared is 25y squared. And I'm done. Okay, so this is all I have for you in this lesson. Hopefully it wasn't too long for you compared to our last lessons that we've had. But anyway, I am done with this, and I will see you in class, and we'll work on this stuff together. Goodbye, everybody.